47. A 0.5 kilogram object is at rest at the original coordinate system. A 3 Newton force in the positive x direction acts on the object for 1.5 seconds. A. What is the velocity at the end of this interval? B. At the end of the interval, a constant force of 4 newtons is applied in the negative x direction for 3 seconds. What is the velocity at the end of the 3 seconds? So first I drew a diagram of the object with the mass of 0.5 kilograms with a force of 3 newtons in the positive x direction being acted on it for 1.5 seconds. Then I plugged in the formula of impulse equals force times the sum of time and plugged in the values. The initial time is just 0, so we can disregard that and solve for impulse equals 4.5 newtons times seconds. Now, impulse equals momentum, so I plugged in the formula of momentum equals mass times the sum of velocity and plugged in those values. And the object starts at rest, so we can also disregard that. This is just 0 meters per second. And we can solve for the final velocity of 3 meters per second. So that's the end of part A. Then for part B, I redrew the diagram. And the difference here is that it starts at 9 meters per second already, so the initial velocity will not be 0. And I plugged in the same formula. Impulse equals force times the sum of time. Again, the initial time is simply 0, so you may disregard that. Then plugged in again momentum. The sum of momentum equals mass times the sum of velocity, and plug in the values. Now, newtons times seconds is equal to kilogram times meters per second. So when I divide a kilogram from a newtons times second, it just makes meters per second. And then so they're in the same units, so I can subtract the 9, or add the 9 rather, and that gives me my answer of negative 15 meters per second.